Okay, so here's example 5, integration by parts. This one's different than all the rest of the examples, and here's why. Notice your integral. You're taking the integral of secant cube x, okay? So if I want to use integration by parts with that and using that mnemonic, well, what do you do here, okay? Well, I don't. If you look at your integration table or your basic integration formulas, all right, you do not have an integral of secant cube x. What you do have is the integral of secant squared x, or secant squared u du, okay? So therefore, what we're going to do is we're going to separate this secant cube x into secant squared x times secant x, okay? Now, the question is going to be, though, which one's going to be your u and which one's going to be your dv, because they're both trig functions, right? Well, the solution to this is that the most complicated portion of the integrand can be easily integrated is secant squared x. So you should let dv be secant squared dx and u be secant x. So this is what I wrote in red to explain why. Notice that when you take the integral of secant squared u du, look how easy look how easy the integration is. It's just tan u plus c. Okay, but if you compare to the integral of secant x, if you take the integral of secant x, look at this integral. That's the natural log of secant u plus tan u. So therefore, we want our dv to be the portion, okay, and that looks most complicated, but it's easy to integrate. Okay, so we want our dv to be that secant squared x, because secant squared dx, because it's easy to integrate. Okay, versus letting our dv be the secant x. Okay, so we're going to let dv be secant squared dx and u be secant x. All right, so here we go. Let's start this thing. So I'm going to let u equal secant x. Okay, and we're going to find v, and then we got du. Well, what's the derivative of secant x? Well, that's just secant x plus tangent x dx. Okay, so what's my dv? Well, my dv we chose to be secant squared dx. That we just explained that, right? Now the integral of secant squared dx we know is just tan x. And here we go. Now we can do our integration by parts. Now this is going to be something else, okay? Now, so you might need extra paper besides these PowerPoint notes that I have uploaded to Blackboard. All right? So first thing I'm going to do is I'm going to write the integral of secant cube x dx, okay? So I'm going to have u times v, okay, which is going to be secant x times tangent x minus the integral of tan x of v times du, of tan x times this secant x plus tangent x dx. Okay, now when I multiply this tan x times this tan x there, right? Okay, actually, why do I have a plus here? That should not be a plus, class. I'm sorry. Let me correct that. That's the derivative of secant x is secant x times tangent x. Okay, I don't know why I put a plus there. So secant x times tangent x dx. Okay, so it's going to be minus the integral of v du. So it's going to be tan x times this tan x, right? It's going to be tan x squared, or tan squared x. So I'm going to have secant x tan squared x, okay, dx. All right, now what do we do? Well, we're going to have to take the integral of that, correct? So what we can do is there's a trig identity that we can use, okay? So the trig identity is, I know that tan squared x is secant squared x minus 1. So I can rewrite this as the integral of secant cube x dx is equal to secant x tangent x minus the integral of secant x parentheses secant squared x minus 1 dx. So I'll just use the trig identity there, right? And then the next thing I'm going to do is I want to distribute that secant x into this parentheses. And I'm going to rewrite all over again. So here I go. The integral of secant cube x dx is equal to secant x tangent x minus the integral of secant cube x minus secant x, all parentheses, dx. Okay? All right, so here we are. Now I have this integrand I have to deal with, okay? Now watch this, okay? I'm going to have to take the integral of this piece right here. So I'm going to separate them into two different integrands, okay? So now when I separate it, in other words, this is all in brackets, okay? So here I go. Now remember, this is negative integral. So when I take the integral of both terms, it's going to be the negative integral. Let me do that again. Highlight in blue. This is going to be the negative integral of secant cube x and the negative integral of negative secant x. Okay? So here I go. The integral of secant cube x dx is equal to secant x tangent x minus the integral of secant cube x dx, okay, minus the integral of negative secant x dx, okay? So that's how you rewrite that. Well, these two negatives here are going to make a positive, right? So I'm going to rewrite it again with that. So it's going to be, with that said, I'm going to rewrite it again. So secant cube x dx is equal to secant x tangent x minus the integral of secant cube x dx plus the integral of secant x dx. Okay? So it's just a lot of rewriting. Now, here I go. I want you to notice something here. What's going to happen is, you see this piece right here? If there's no way that's going away. If you notice, I already took the integral of the secant cube x dx. I split it apart, right, into secant squared x and secant x using integration by parts. Okay, so here I have it again. All right, there's no need to go through this again, because if I take the integral of that again, I'm going to go through the same thing over and over. So I'm in this loop here that never ends. Okay. All right, because that's what I'm taking the integral of. That's what I'm taking the integral of, and here I have it again. So when this happens, when you have a repeat of what you're taking the integral of, you can stop taking the integration by parts, okay? Because I can just take this right here and add it over to the other side. So I can add this integral of secant cube x dx on both sides here, okay? So this cancels out. And so this secant, the integral of this secant cube x dx plus this secant cube x dx is going to be what? It's going to be 2 integral secant cube x dx is equal to, I'm just going to rewrite it, secant x tangent x plus this integral of secant x dx. Now watch. Now I can take the integral of secant x dx. What is the integral of secant x dx? The integral of that secant x dx here, okay, this piece right here, I can go ahead and take the integral of that. That's going to be the natural log, that natural log, right? That natural log that we were talking about, okay, which is going to be the natural log, the absolute value of secant x plus tangent x plus c, okay? All right? Now, again, so see what happened there? So when you have a repeat of what you're trying to make the integral of, you might as well go ahead and stop and just add it or subtract it over depending on the sign. Because this sign is negative, I'm going to add it over, right? Now I got this 2 here I'm dealing with. Now, I don't want 2 times the integral of secant cube x dx. I just want the integral, I just want this piece, right? I want to solve for that. So that means I got to divide everything by this 2 that's in front of it. So I'm going to divide everything by 2. So I'm going to divide this by 2. And then this by 2. Well, that's the same thing as multiplying by 1/2. So therefore, my final answer is going to be the integral of secant cube x dx is equal to 1/2 secant x tangent x, I forgot my x here, okay, plus 1/2 natural log of secant x plus tangent x plus c. And that is my answer, okay? That's how you work this example 5.